Well, I thought, now, there's two ways from what I've been told, that you could either drill or you could just go down like 4 feet and run like a, well, below the frost and like run a trench, a lot of it. There's for just houses. I've been told.
Yeah, you're talking about a horizontal loop or a vertical loop. And you can, this will work in, it's basically an equation. There's a certain number of BTUs, or heat, British thermal units, for every distance. And so the problem with this is, in a New Hampshire winter that's so long that even though it's below the frost line, your loops would have to be gigantic in order to get enough heat out of the earth at that level. And so what you see in New Hampshire is a lot more vertical installations than horizontal. Now, there are ways to get around this. If you have a lake or a pond, a lake or a pond can store a lot of heat, even in the winter. You can run the loops in the bottom of the lake, and you could, as you get further and further south, what you find in the south is a lot of geothermal systems that are horizontal loops, because in the south and the southwest, when you design a geothermal system, you're not designing it to heat, you're designing it to cool. And so it's a lot easier to cool with these kind of systems than it is to heat. But in New Hampshire, we really focus on the heating side, and so that's why you find the vertical systems. Now, the real trick is kind of combining these systems, like having a partial solar thermal and a partial geothermal or something like that. And the idea that you can get them to work together is really intriguing. Or in Canada, they built this subdivision. It's an entire subdivision. Picture of this one. And what they've done, this is really tricky. Huge, hundreds of houses, right? In this huge subdivision. And on each of the houses, there are solar thermal systems on all the garages. And through the entire development, there are these pipes. And they all pump to this big, giant central building, this heat. And in the building, if we look from the side, you see there are these giant concrete plugs in the ground. Huge, thousands of cubic yards of concrete. And what they did is they just dug down like, I think 100 feet, and put these plugs in, and then they have all these loops. And so actually, technically, what's happening in this subdivision is all summer, these solar panels are heating these gigantic plugs of concrete. And then what they do is they have a pump here, and in the winter, they reverse the pump. And so all the heat comes out of the concrete plugs and goes into the houses. And so you get this solar thermal effect that instead of changing once a day, as the heat comes out of the panels when the sun goes up, it changes over a course of 6 months. And so, yes, they get a little heat from the solar arrays during the winter, but the lion's share of the heat is stored all year long in these gigantic concrete plugs.
That'll last 6 months?
Yeah. It's pretty amazing. There are some systems, there's some group up in Canada. Now, Canada's way ahead of us because it's a crap load colder up there and for a longer time, and so they're really into this stuff. There's some company that's trying to come up with a 3-year storage tank device or something, so that they would build it. It's all insulated, so it doesn't even pick up or lose heat to the ground, and that you would be able to charge it. It takes a couple of years to charge it, but once you charge it, it would be able to provide heat for a period of 3 years. And all that can be calculated out. It's very easy to learn because each one of these plugs can take a certain number of BTUs. Any other ideas, questions, walkthroughs, go through the building? One of the things we talked about in the other classes, one of the things that they did at UNH last year was over the Thanksgiving break, the energy office, I think it was the energy office, that tried to send out to all the students and teachers to unplug your computers over Thanksgiving. And it was kind of an experiment, but when you leave a computer plugged in, even when it's off, it's technically still sucking power. And when they did this, they unplugged all the computers, and it was a dramatic change in the amount of electricity that campus drained. And the idea that, I've walked through a lot of schools at night when people have left and the little orange light is on the monitor. That means, yes, it's in standby mode, but it's not completely off. If you unplug it, you're going to save a lot. And I know that one monitor doesn't make that big of a difference, but when you think of how many computers are in this school, if you were able to unplug every single computer, you could actually save a pretty significant amount of electricity and money. There's a little device called a kilowatt. You can plug something into it, and it'll show you exactly how much electricity it uses. The best things to plug that into are things like
Refrigerators.
yeah, drink refrigerators and stuff. They really take a boatload of electricity, and it's because of all those compressors. We were talking about everybody is trying to get people to switch out their refrigerators because they're on 24 hours a day, 7 days a week. And when you buy an Energy Star refrigerator, you really save a lot of money. The problem is that most people, when they swap out their refrigerator, they take their old refrigerator out, put in the new one, and then what do they do with the old one? They put it in the basement and plug it in again. And so you end up defeating the purpose, because now you've got all your main refrigerator upstairs saving you money, but the one downstairs you may have, you know, some food in it or some meat in the freezer or something like that, but if it's not full, it's actually working even less efficiently. And so the idea is that when you replace something, you get rid of the old one so that you make sure you do the savings. Just walk around this building, you know, walk around in any school. Computers, people have their cell phone chargers plugged in, electronic devices, clocks, VCRs, CD players, all that stuff gets left on, and you end up taking a lot of money. One of the real killers, have you seen those Keurig coffee makers? The single coffee maker?
Good.
Oh, yeah.
You get,
Good coffee.
It's
So
great
good.
coffee.
Good coffee.
You get, just for fun, you got to get one and plug a kilowatt into it and see what it does. I mean, it goes up to like 7 kilowatts. It'll probably be the biggest electric draw in your house. Granted, it's a short burst because it's trying to heat that water so quickly, but it's a lot of power that gets sucked into that thing, and it's really kind of entertaining to start to know. But luckily, it's only that short burst. A regular coffee pot, what would be an interesting experiment to see if a regular coffee pot left on for 2 hours, how much electricity that uses versus a Keurig that's left on for 2 hours and only used a couple of times for a couple of cups.